This is one of my favorite trigonometric integrals out of all the integrals that we have been solving. Integral of 1 over cosine of x minus a times cosine of x minus b. Notice that there could have been all different combinations possible. It could have been cosine times sine, or sine times cosine, or sine times sine. Okay, so there are really four combinations possible in this example. If you observe carefully, all of those four combinations are the terms of the compound angle of sine and cosine. Okay, we know that sine of a plus b, which is the compound angle of sine, is sine a cos b plus cos a sine b. If it is negative, then it is negative here as well. And for cos a plus b, it is cos a cos b minus sine a sine b. If it is plus, if it is minus, it is plus over here. Okay, so this term cosine times cosine is the term which is occurring in the compound angle formula of cos. Okay, there could have been other combinations also possible. In order to integrate such a pattern, there is a golden rule that we follow. What you observe really is whether the term that you are seeing, does it occur in the compound angle formula of cos, or whether it is of the compound angle of sine. Okay, and then you multiply divide by something. Let us see the exact rule over here. So the exact rule says that whenever you see 1 over cos x minus a times cos x minus b, or if you see sin x minus a times sin x minus b. In other words, if you see the terms of the compound angles of the cosine, okay, because these two are the terms which are for the compound angles of cosine. Whenever you see the terms of compound angles of cosine, you multiply and divide by the opposite, which is sine of the difference of the two angles. Okay, the difference of the two angles is x minus a and x minus a minus x minus b. The rule number two is the exact same idea. If you see the compound angles of the sine terms, which is sine times cos or cos times sine, if you see those two, the opposite is what you multiply and divide by. So you multiply and divide by cosine of the difference of those two angles, which is x minus a minus of x minus b. I hope this is clear. We can also keep it simple and say if the functions in the denominator are same, like cos cos, or if it is sine sine, just multiply and divide by sine. If the functions in the denominator are different, like sine cos or cos sine, just multiply and divide by cos. And remember, angle is always the difference of the two angles. Okay, difference of the two angles present in the denominator. Okay, whatever those may be. Now let us integrate this term cosine times cosine. Notice that that's the term present in the compound angle formula of cos, which is why we will multiply and divide by the opposite, which is sine of the difference of those two angles. So that integral will now look like integration of, I multiply and divide by sine of the difference of those two angles. So sine of x minus a minus x minus b. Okay, and then I divide by the same term. So sine of x minus a minus x minus b. And I already have in the denominator the original term, which is cos x minus a times cos of x minus b. Now let us see how to solve this further. We can apply the compound angle formula on the term in the numerator. So we can apply sine of a minus b. Okay, remember that sine of a minus b is sine a cos b minus cos a sine b. So the numerator will then look like sine of x minus a times cos of x minus b minus cos of x minus a sine of x minus b. I just apply this result right here. Okay, this is my capital A, this is my capital B. All right, and in the denominator, I have cos of x minus a times cos of x minus b. Okay, and this term, what I do is I don't apply the compound angle formula. I just subtract those terms. Okay, so if you subtract this, this x and x will get cancelled over here. Okay, and I have minus a, and this minus minus b is plus b. So essentially, I have b minus a. Okay, so in the denominator, along with this term, I have sine of b minus a. Okay, because this x and x will get cancelled, and I have negative a and I have positive b. So what we can do at this point, it is very easy to integrate. This term is constant, can be taken out of integral. So my integral will then look like 1 over sine of b minus a. Okay, integration of, and the remaining term, which is cos x minus a times cos x minus b, I can split this term in both of those terms in the numerator. So what that will do, it will cancel a lot of things. So it will give me sine x minus a cos x minus b. I give the denominator term to the first term in the numerator, which is cos x minus a cos x minus b. Okay, then I have minus. I give this denominator term to the second term in the numerator. So that will give me cos x minus a sin x minus b divide by cos x minus a and cos x minus b. Remember that is with respect to x over here. Okay, all the time I have dx, which means with respect to x. Now, many things can get cancelled here. Cos x minus b will get cancelled, and cos x minus a will get cancelled over here. Okay, so basically what I have at this point, I have sine x minus a divided by cos x minus a, which is tan of x minus a. And over here I have sine x minus b divided by cos x minus b, which is tan x minus b. So this will just become sine of b minus a, 1 over sine of b minus a, integral of tan x minus a minus tan x minus b. And I have that integral with respect to x. Did you see that how that complicated integral turned out into such a simple, just two terms of tan by doing the trick that we used? Okay, now we know the integral of tan x is log of sec x. Okay, so now this will become 1 over sine b minus a. Okay, I'll put a bracket. Integral of the first term, which is tan of x minus a, is nothing but log of sec x minus a. I can put log mod because it cannot be negative. So log mod sec of x minus a. Coefficient of x is 1 over here. So you can divide by 1 or it doesn't matter because it's anyway 1. Remember in integral we always divide by the coefficient of x. In this case it is 1, so it doesn't matter. Minus integral of tan x minus b is log mod sec x minus b. I'll close the bracket. Let's add the constant of integration. See, and now we can clean this up a little bit. This is log a minus log b can be written as log a divided by b. So this will become 1 upon sine b minus a. So log of mod of sec x minus a divided by sec x minus b. And let's close the bracket, add the constant of integration c. And this is your final result. I hope you found this trick helpful.